This video is going to have a look at two things. The first part is going to be to have a look at how esters can be used to make soaps and how soaps work, and then the next one is going to be used to have a look at how esters can be used to make margarine. So first things first, soaps. There are three key things you need to know from this. A soap is made by taking an ester, which we had a look at in the previous video, and reacting it with an alkali. Any soap has two parts to it, a hydrophobic and a hydrophilic end. Hydrophobic, as you can probably get from the phobic bit, is water heating, so it tries to get away from the water, and hydrophilic, water loving. It's really important you know those two words and what they mean for the exam. So the first thing you need to know is how to make soap from an ester. So start off with your ester and react it with an alkali. So what you do is you take your ester. Now esters can be fats or oils, and you react it with a concentrated alkali. Now if you think back to the one that you did in lesson, you had 5 molar sodium hydroxide. You can also use potassium hydroxide and other esters out there. When boiled, which obviously you did during your practical, the fat breaks down into glycerol and carboxylic acid. It's this carboxylic acid here that then reacts with the alkali to produce your salt and water. So simply put, your soap is a salt, usually sodium or potassium, that's been made out of a long chain to carboxylic acid. Right, the next bit is going to show you how these soaps work. If you have a piece of clothing, like I've got down here, with a dirt or stain on, when you put the soap into it, as we've said before, the soap has two parts. The hydrophobic part and the hydrophilic part. Now, because the hydrophobic part hates water, it will try and get away from it. Now the best way for it to do that is to bury itself into the dirt. So when you put your suds, your soap, into your wash, the hydrophilic part is still outside of the dirt, touching the water, and then the hydrophobic part is buried inside the dirt. Now eventually the soap, which is actually an anion, will surround this and form a droplet and will help to pull it away from the clothing. This allows the water, when it's rinsed, to wash the dirt away and leaving the clothes nice and clean. Okay, the next part is going to have a look at margarine. So by the end of this part you'll know what margarine is, how it's produced, and why. If we wanted to make margarine, what we'd do is we'd take an unsaturated oil, and I'll show you what that is in a minute, and we hydrogenate it. That will produce saturated oils, which, for example, your margarine is. So here I have part of a chain of an unsaturated oil. Unsaturated, if you remember back to year 10, is something that doesn't have a full amount of hydrogen in there, so it's got double bonds. Okay? So what they do is they take this double bond and they add hydrogen to it. This process of adding hydrogen to break and fill in the double bonds is called hydrogenation. So adding hydrogen to fill up and use up the double bonds. To speed up the reaction, in this process they'll use a nickel catalyst. Therefore the name of this process is catalytic hydrogenation. Now if you remember again back to the earlier stuff that you did in year 11, catalytic means using a catalyst, something that speeds up the rate of reaction without getting used up. So the conditions you need for this are high temperature, high pressure, and that catalyst, which if you remember I've just said is nickel. So what they'll do is they'll take your unsaturated fat there, which is your oil, add hydrogen to it under these pressures. It'll break that double bond, fill it in, and turn it into a saturated fat. And a saturated fat, when it's cooled down, will be solid. For example, your margarine that you put on your bread. Now, in margarine, for example, not every double bond is broken up and turned into a single bond. There are still some in there, which means it's a monounsaturated fat. That means that it's still spreadable and not too hard, not too solid.